All right, so example 3, we're now talking about solution stoichiometry. So in mass stoichiometry, we typically used mass equals moles times molar mass, right? Because we were dealing with solids and other things. Now we're dealing with solutions that are typically aqueous or liquid, and therefore we need to use concentration equals moles divided by volume. Okay, we need to use that formula. But the process, guys, is identical. How we find the moles, we just tweak it. That's it. So in this example, it says that you have sodium hydroxide neutralized with hydrochloric acid. So sodium hydroxide is a metal hydroxide, which is a base. I'm reacting it with hydrochloric acid. I am neutralizing it. Neutralize means produce water, okay? And we know that a neutralization reaction is acid plus base equals salt and water. So let's take a look. If I have sodium hydroxide, okay, I know that although it's an ionic compound, guys, when I put that in water, it's going to dissociate. So I'm going to write aqueous. I'm going to react that with hydrochloric acid, which again is aqueous, meaning that these are both solutions. And I'm going to produce a salt, NaCl, ionic compound means salt. Again, it's aqueous because it dissolves in water. And I'm going to produce water. Okay, this is a neutralization reaction. Acid base, salt water. I got to see if it's balanced. Okay, so I've got one sodium here, one sodium there. I'm good. One chlorine here, one chlorine there. Good. One O, two H's, two H's. We're good. Now, in this question, it says, so the first step in molar coaster, balanced reaction, have that. Second step in molar coaster is the moles. Now, it's given us a couple different things. It's given us the volume, it says, what volume of sodium hydroxide? So I'm looking for volume of sodium hydroxide. It's given me the concentration of sodium hydroxide, 0.214 moles per liter, okay? And it wants me to have volume, okay? So let's just write down that information. I'm looking for volume. I have concentration. Now, if I look at HCl, it says it's given me a concentration of HCl, 0.0104 moles per liter. It's given me concentration. And it's also said the volume is 500 milliliters. Okay. Well, first of all, I've got liters here, so I need to convert this to liters. So I divide by 1,000. Well, if you look and you think back to solutions, you'll remember that moles is equal to concentration times volume. Do I have the concentration? Yeah. Do I have the volume? Yeah. Concentration, 0.0104 moles per liter, and the volume, 0.500 liters. Liters cancels. And in my calculator, I'm going to type that. So 0.0104 times 0.500 gives me 0.0052 moles. Okay, put a box around it. Don't round that number. Okay, keep all the numbers. So molar coaster, guys, says that I need balanced chemical equation. We have that. And the moles of one chemical, we have that. Now the question is asking me for the volume of NaOH. I have the concentration. If I rearrange this formula to isolate for volume, I'm going to get volume equals N over C. Well, I have the concentration, but I don't have the moles. So I have to ride my molar coaster. I have to divide by where I start, which is 1, and multiply by where I'm going, which is 1. So the moles are the same. This is what we call a 1-to-1 relationship. So to figure out what the volume is, I'm going to take my moles, 0.0052, and I'm going to divide by the concentration, 0.214. Moles is going to cancel. And I'm going to get 0.02429 ... liters. Now, if you were going to go up to somebody and say, I need 0.0249 liters, they're going to be like, it's a little weird. When the number is very small, we can keep it in liters or we can convert it to milliliters. So I'm going to go up here. So the volume that we got with proper sig digs, I need 3 sig digs. I would get 2.43 times 10 to the negative 2 liters, or I can multiply my liters by 1,000 to get milliliters, and you would say 24.3 milliliters. Both of these, ladies and gentlemen, are acceptable answers. Okay, you just have to look at what the question is asking.